So let's take a look at the rest of the homework, starting with number 21 here at the end of chapter 6. So if we go to page 162. Problem number 621 is right here in the middle-ish of the second column. So we have a reciprocating saw, looks kind of familiar. Use the relative velocity method to graphically determine the linear velocity of the blade, okay, as the crank rotates 1500 RPMs counterclockwise, okay? This is a slider crank mechanism. It will be the same process as we did for problem 620 in our practice problem. So it's almost identical to this, except this is offset a little bit, okay, as far as diagram wise, okay? But process exactly the same, okay? So you know everything about the crank, and you want to find what is the velocity at this moment in time, magnitude and direction for that blade, okay? That's a slider. So that's going to be your first problem. So use 620 from our handout as your guide there. The next one that you have to do is going to be 623. Here we have a shearing mechanism. We've drawn this one before. Use the relative velocity method to graphically determine the linear velocity of the blade as that crank rotates 100 RPMs clockwise. Okay. So this is another slider crank. It's just oriented vertically this time. Same process as the previous problem and at 620 in our handout, right? The next one that we have is 628. 628 is right here. It starts at the very bottom of page 162 in the first column. The device in 627. So you already have this drawn, okay? The sloshing bath is used to wash vegetables. For the configuration shown, and it goes up to the next part here, use the relative velocity method to graphically determine the angular velocity of the water bath as the crank is driven clockwise this time, 75 RPMs. Last time it was counterclockwise, 100 RPMs, okay? So we have a different direction and a value on our crank, but the diagram is going to be identical. So your lines of action for your vectors will be the same, but BB will be different because it's going at a different speed and it's going in a different direction, okay? But process-wise, exactly the same. And then our last one is 631 for the hand-operated shear here, okay? Right down here. Determine the angular velocity using the relative velocity method to graphically determine the angular velocity of the handle, okay? The angular velocity of the handle. So it's going to be actually W2 that we want to find with when the blade is actually going at a rate of 3 millimeters per second as it's cutting through the material. Okay, so it's going down at 3 millimeters per second. What is the angular display or the angular velocity of our handle? You do not need to determine the linear velocity of point X, okay? Only the W2 if you would, because that's going to be your input, your crank. So you're actually going backwards from the slider to the crank. So it's just a different order. I know you can do it. So I'm going to have you guys just kind of use what you know, then work in the opposite direction. Work from the slider to the crank instead. All right. So any questions? All right. So that's what we have for homework. Using the practice problems that we did in our handout, make sure that you include information as we did it there. Lex, you have a question.
The practice problems, it says handout example 6.6, which we replaced with those two homework problems.
Oh, correct. I'll take that off. Yep. Well, the homework problems were part of the handout. Do you know what I mean? So we did it, we actually just didn't do the extra practice problem yet. Jack is like, he's on board still, I think. Um, so yeah, if we go back to, so I'm just gonna go there because that was a good question. So I will go to our practice problems for module 3, and I will edit this, and I'm gonna take off example 6.6. How does that sound? So still any of the examples, those last two examples, 620 and 627 were part of the handout. Those are required. Yeah. But we took off 6.6 officially. Yeah, scan the packet or take pictures as long as I can see it. Yeah, double check. So when you're handing in your practice problems for the handout portion, you can scan it or take pictures, making sure that they're readable and not grainy. Okay. Any other questions pertaining to the assignment or the practice problems? Okay. All right, then I'm going to stop this recording.